All right, we're going.
Woo! As I'm yawning. Good sound.
All right, so let me minimize that so I can get into the homework.
Woo! Best part.
All right. All right, sorry, I got to get all the way into the homework.
No problem.
You are just fine. I'm gonna get some scratch paper.
Right. Yeah, you got to have your calculator, your pencil, and scratch paper, and your homework. Okay, group meeting.
Woo-hoo-hoo.
Okay, question 1 and 2.
They're both true.
Okay, awesome.
Yes, ma'am.
All right. Find the margin of error for a 90% confidence level when the standard deviation is 50 and n is 25. Okay.
That's Z times standard
The
deviation over
margin of error
It's
is 90,
1.5.
90%. So it's going to be 1.645.
I think you're just supposed to do 1.65 though.
I think that's where we end up. That's where this makes me crazy. Or it's 25.
Okay. Well,
Because if you go on like the reading, it has it listed as 1.65.
Well, I'm looking at the book. I mean, at the notes, and they say most commonly used values for Z are 90% is 1.645, 95% is 1.960, and 99 is 2.576. So
yeah, that's what I have too. I'm going to go.
they give it 3 points in one place, and then I think there's one other place that they put it down to 2. So I think it's confusing in the book.
Yes, that's true. Because, like, in question 11 on the homework, it does say 1.65. Oh, well, I'll compute it for 1.645, and someone else compute it for 1.65, and let's compare the difference.
Okay, I'll do 1.65 then.
And then, so we got the confidence level, and then we're going to divide it by, it's 50 divided by the square root of 25. Okay. Oh, I need my glasses.
So I got 16.54.
I got 16.5 exactly.
I got 16.45.
What?
Oh,
Okay,
you got 4 or 5? Oh, yeah, I times it wrong. Yeah, it
what
is.
did you get, Katie?
16.5. I think because I rounded the 1.65 instead of 654 because
Right.
the full one. Mine, that means the answer is just going to be rounded, but yours is probably going to be more.
Well, and it says round to 3 decimal places.
So
Then
we go to 16.45.
50.
Okay, let's do that.
Very good. Guys, ready for the next one?
Yeah.
All right. Which of the following statements is true? Population mean is the point estimator of the sample mean. Sigma is an interval estimator of sigma squared. Sample mean is a point estimator of population mean. And sigma squared is an interval estimator of sample mean.
Wow, the first one and third one is just saying in reverse. They're the same thing.
It's not going to be an interval estimator because
No, because
that would be an interval estimator is
2 numbers.
yeah.
So no.
And a point estimator is one number that, or a specific value that is an estimate of the parameter. And so it would have to be that the sample mean is a point estimator of the population mean. Does that make sense?
So you think the third one is right?
If yours are in the same,
Yeah, this x over x is a point estimator of the u, is what you're saying.
yeah.
I think it's the first one. U is the point estimator of the x.
No, it can't be because a point estimator is a number that estimates a parameter, and so U is a parameter.
Okay. All right, let's do that.
Does that make sense?
Yeah, I remember marking that because it had a thing.
Well, it's interesting that they put it that way because.
Yeah, because at one point they say it goes either way, and that was an important concept.
Right.
A point estimator gives one specific value as an estimate. An interval estimator is a range. That's not what we're looking for. Let's see. Says a confidence interval estimator.
So, what you're thinking
commonly used.
with the it can go either way is actually with the sample mean will be this many units away from the population mean, and the population mean will be that many units from the sample mean. But all it's asking is at the beginning, it's talking about that is a point estimator is pretty much the specific sample number that's an estimate of the population.
Under 3.1, where it talks about point estimators, it says the short answer is that we will never know for sure if X, with the line over it, whatever that's called, is close to mu. But it says, think about it. If M is unknown, let's see. Never mind. I was thinking that it made it clear.
Yeah, it's only asking about how it says that point estimators are just one number that is used to estimate a parameter. And if you look at the chart, the parameters are mu and sigma squared.
Right.
So.
All right. Okay.
Okie dokie.
Okay, let's go. We'll go to the next one. That's kind of an interesting thought, though. All right, question number.
Bye.
Okay, Gina wants to construct a 95 percentile confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample of 64 and computes X to be 526. Use the information 5 through 8. What is the lower limit of this confidence interval? Okay, so we need to find our...
So it equals 1.
Okay, so...
0.60 plus or minus 1. So it's the minus part of X. So it's 526.
Plus or minus the 95 percentile is
96.
Is 1.96. 1.96 times
over the square root of 64.
113 over.
We just have to do the negative.
Yeah, we just have to do the negative right now.
Yeah.
Okay.
Oh, whoops, I added instead of subtracted.
You guys get an M score of 27.685?
Oh, yeah. But now you just need a minus by 526.
Right.
So what did you get?
She's still working on it. I have 498.315.
That's what I have. 498.315.
Oh, I don't know how I got 498.07. I wonder where I went wrong on my.
What did you get 27.685 for your M score?
Let me do that again and make sure. Let's see, I got 1.96 times 15.125. I got 27.685.
Yep.
Right. And then subtract that from 526.
Or subtract 526. Yeah. Yeah. No. You're right. Never mind. I don't know what that.
Oh, okay. That time it worked. I don't know.
Okay. All right. So 498.315.
Perfect.
Okay.
Well, add it.
All right. Now we just have to add it.
That would be simple. 526 plus 27.685. 553.685.
That's what I got. Monica, is that what you got?
Yep, 685. Yes, it is.
Okay.
Okay, 7. What would happen to the width of the confidence interval if Gina increased the sample size?
It would decrease.
Yes.
Everyone in agreement.
What would happen if the width of the confidence level of Gina increases the sample size? Decrease.
Because the sample size makes a bigger number to divide from, in the denominator.
Okay.
Okay, what would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval? It would get wider. It would increase.
Bigger. Yeah. Uh-huh.
Okay. Bright Bulb Light Bulb Company. Well, that's an interesting name. Is doing a study to assess the average life expectancy of their light bulb. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need?
All right. So that
Equals N equals.
is
95% is 1.96 times by
okay.
standard deviation, which is 400, over margin of error.
Which is 05, right?
What?
The okay, nothing.
Over 50. No, it would be over 50.
Yeah.
And then you square that.
Oh, I forgot to square it.
You gotta square it.
$245.862. Is that what you guys got?
I computed it wrong. Or something.
So it's 1.96 times 400, correct? Divided by 50, all squared.
Yeah, and I got like I had something I know isn't right, so I don't know if I just put.
Okay, wait. I'm still just a little bit confused here. Okay, 95%. So it would be 1.96 times O, which is
400.
Wait, how come you get 400?
Because it's a standard deviation.
Okay, sorry. No wonder, I'm looking at the next question. Okay. Times 400, you're right. And then divided by?
Divided by 50.
Did you say 245.8624?
Yes.
Okay, cool.
245.8624. And so 862. And we have to round up to the nearest whole number, so it'd be 246. Are you there, Pam?
No, where do you get the 245?
Okay, so times 1.96 times 400.
Divide by 50.
You got that?
You mean, okay, you got okay, oh, I see what you're saying. Okay, yes. Okay, yes.
Okay.
Okay, divided by 50 and then square that.
And then square it.
Okay.
And then you have to round up to a whole number.
Right. And square that equals, okay, what did you get?
246. Well, without rounding, it's 245.862.
Right. Is that what you got, Katie?
Yeah.
All right.
And so you're 246.
246. Oops, where did I put that? All right, okay. All right.
Okay. The mean salary of actuaries is 100,000 and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with the level of significance at 0.05, and your
hypothesis is this, and alternate's that.
Okay. So you collect a simple random sample of n equals 36. Women's salaries find that x equals 111,000. Use the information for questions 10 through 12. What is the lower limit of the 95% confidence interval?
Wow, okay. A lot of stuff.
That is a lot of stuff.
We just have to sort through it right. Okay, so our
x is 111,000.
We're doing the lower limit, so minus.
Plus or minus.
Minus the.
We're just doing minus right now.
Right.
So minus, and the z-score is
1.96.
Times that by 36,730 divided by the square root of 36, right?
Yes.
That's our.
Yes, ma'am.
All right, let's figure it out.
Okay. Keep losing my calculator here. Clear.
Three, 6, 7, 8, 36.
Did you get 99,001.53?
I did something wrong.
Oh, good. Oh my gosh, that's amazing. That's exactly what I got. 99,001.53.
Yep.
Oh, round to the point, whole number, so 99,002.
Yes. Is that what you got, Katie?
I think I forgot to put a decimal or something, so I have to like redo it.
Dude,
Okay.
but just so
I
you don't.
times it by 196, not 1.96, so I have to redo
Okay.
it real quick.
But I got the M value being 11998.467.
Yep. See, I did it the first time and I got like this huge number, and I was like, whoa. Put it in again. Okay, you guys got 99,001.5333.
Yes.
Cool. So the nearest whole number, right?
I just made a mistake and compared my pregnant daughter-in-law to my pregnant dog and really got in trouble.
My goodness.
You are in trouble.
Yeah, uh-oh.
I wasn't thinking, God, that this is the son that does not like our dog.
Oh.
Oh, that is funny.
Oh dear. I was wondering why it's buzzing so much.
Oh, shoot. Sorry about that. Okay.
So
What is the upper?
99,002.
So now we just have to add it. I got to stop playing around. Sorry.
Wait, so is it 99 or 99,002, right?
Yes. Yeah.
Okay.
Oops, I put a point, not a point.
Okay. So the next one.
We just add it.
Which would be 122,998.
One, 22998.
But we have to round up.
Right.
So it would be 999.
Well, no.
Wait, no, we don't round up for this because it's not the population one.
Yeah, it's a
Yep.
dollar. It's money.
Yes.
It's money. So you round to the nearest.
It says round to the nearest whole number.
Right. Which would be the 998 because it's 998.467.
Yeah. You would round as normal. You wouldn't round like
You
because
would round up, yeah, because this is dealing with money.
Okay, so did we do the other one wrong? Oh, wait, no.
No, I think the other one was right because it was dealing with people.
well, the other one, the one we just did was right because it was 5, like 0.5, not 0.4.
Yes, right.
Sure, I agree with this. Oh, because we have the N as people. Okay, sorry.
Yep.
You're right.
No worries. Okay.
122,998. Correct?
122,998. That's what I got.
Okay.
Okay. Now, there are 3 requirements that need to be checked when computing a confidence interval for a mean. They are a simple random sample. Yes. The X is normally distributed. Yes. And O is known. Is known.
Yep.
Yes.
So it's all of the above.
Right. Are we done?
Yeah, we're done.
I'll submit it.
Okay.
I think it's my turn. Wow, they're all correct.
Yay! We're so awesome.
Yeah.
Just clarify, because I'm